It's gone well. So you're finding the acceleration from the second one. The second question, you're finding the acceleration. You're finding the acceleration. This is currently the same lesson. I'll go around and check. So please, tomorrow's class will be all about, Saturday class will be all about your physics manual and the practicals. So just solve few questions for the practical, then we'll enter the physics.
Who has power?
Please, if you're just coming in, check the PDF. That's what they are doing. Okay, let's confirm. So you are done with the first two questions. Let me see. Okay, read the first question. Okay, wait. See, the first question from the PDF is a block. That is M is 120. Kg. Okay, it's pulled horizontally by force of 10 Newton.
Along the frictionless.
Okay.
What is the acceleration of the body?
What is the acceleration of the body? Just like this. This one is too simple. Show me? This one is just F equals to M. Because the total that is frictionless. That means there is nothing like backward. Show me? So let's say this is the block. 120 kg. Now it's being pulled by 10 Newton. See, I think the effect friction is here. We have something like this. But then you said frictionless, so no need. Okay, assuming there is friction here, what would be the equation of this motion? We have 10 minus Fr should be equals to M. But provided they did not provided they didn't give us the Fr, there is no friction. So it's simply F equals to M. Set as a vec equals to 120 A. Is it not true? So when we get started on the phone, I will grab us like 120. And what do we have A to be? 0.08. And it's a meter per second. So I think what we started with this simple question is for us to still remember that force when there is no friction is simply F equals to M. Alright. Alright, let's go to the second question. So the second question is a block of 80 kg.
Is equal to the force of 110 Newton.
110 Newton.
The angle of 30 degrees below the water.
The angle of 30 degrees below the sun. So we're finding out. Please, what is the unit of angle? Radian, should we always remember it because sometimes we want to say the degree. Radian is the unit of angle. And we know that radian is a dimensionless quantity, is it not true? Because radian is simply arc length over arc radius. And both of these is given in meter. Meter divided by meter is what? 1. So it's dimensionless. Alright, so to do this, remember the formulas when we started this the first day. I think it's physical science students that I taught that I told them that if you have just one force, F is equal to MA. But if we have a force at an angle, that F is no longer MA, that F now becomes F cos theta. That is the force at the horizontal axis is equal to MA. So there's this mindset we normally have. We always tell ourselves F is equal to MA. F is equal to MA when I just have one force pulling something, there is no friction.
And you say F equals to MA
F equals to MA plus theta. See, it will change your answer for some questions. Yes, because what you are judging is simply the force acting at that axis equals to the mass of the body and its acceleration. But when you do mass and acceleration of the body, cos theta, you are not pushing it against force, which means that that angle is not acting on the force. That is, the force is not acting at that angle, rather it's the body and the acceleration you are putting at that angle. So that's why you need to always remember. Thank God you asked that question. So it's asking me, is it okay to put this at MA cos theta? No. Remember, even when we did all the formulas we'll be doing, we normally do everything to be equal to the mass and the acceleration of the body. You still remember? So at this angle, I will now have force to what? 110 cos 30 is equal to, they gave me M to be 80. Then they gave me HB. Divide both sides by 80. So, punch for me, what do you have? A will be equal to what do you have? Please, everybody punch. So you have 1.19. Okay, that means that this is approximately 1.2. Shady? Approximately 1.2 meters per second. Alright. So before we move to the third question, because I'm using slide to see if you can wait for the non-medical students. I know they are coming, but we can't behind it. Now let's analyze. You know, we've been given formulas. Under dynamics on horizontal axis. So now we're no longer using formula. We want to use those equations we derive, all those formulas, to see if we can solve the question. Which is what we have here. So before we start this question, where I want you to focus your eyes on this steady speed. Whenever they say steady speed, it's the same thing as saying constant velocity or uniform velocity or uniform speed. Are you aware? And at uniform velocity, uniform speed, acceleration will be equal to what? Do you remember? Yes. It's different from when they tell you that something accelerates at constant acceleration. If they tell you something is having constant acceleration and they give you value, just put the value you have to the acceleration. Are we together? Remember how we did this thing when we started? I want to play. So when we did kinematics, we said that equation of motion, that anything moving this way is for acceleration, and anything moving this way is deceleration. Should we? And on this side, remember we have velocity. On this side we have time. Deceleration. Now when they say constant speed, we have something like this. Is it not? So you see that at constant speed there is nothing like this here. See that? At constant deceleration, there's nothing. Constant speed, there's nothing like this here. So it's just this way. Flat. Nothing. So for that reason, if they tell me something is accelerating constantly, it simply means that as it's moving, it's not shaking, no problem. So I'll use the value. It's different from when they tell me constant speed, constant velocity, steady speed. So no matter the value given to me there for them to confuse me, I will know that once it has to do with once it can be, that constant speed can be maybe this 6 meters per second is where you have that constant speed. I say it, but there is no acceleration. So which means anything you are doing here, if something will do today, that thing will have to be zero. Very important. So that's why we are telling this also, because they normally use all this tricking. And when you see it, you might fail. So always remember this, that once you get constant speed, steady speed, that means acceleration equals to zero. Alright, let's now use our formulas to tackle this question. Remember I told you that in tackling this question, don't come and start doing it here. You may ever. Some of you might say you will be careful, you will be attentive, it's good. But I think the best way is simply take it one at a time. I'll simply say for the first mass, which is 200 kg. So I'll say for 200 kg mass. For 200 kg mass, I'll ask myself, what are the forces acting around this 200 kg mass? There's no backward force, Shemi. The only thing I have is resistance to the motion, which is 2 Newton per kg. Then I have the forward force. You know that the forward force for this one will be T1. What do we know? T1. So that means that the force on this system is going to simply be T1 minus, this is 200 kg, minus 2 times 200 is equals to M1A. And remember, they tell me buy a fuel, I get to the filling station, they tell me that they are selling fuel 200 naira per liter. That should be in 2011 or so, Jonathan's time. So if you tell me 200 naira per liter, if I buy 10 liters, it's going to be 200 naira times 10. Is it not true? So when they tell me that I have a resistance of 2 newton per kg, it means that inside here, 1 kg has a resistance of friction of 2 newton. 2 kg will have 2 times 2. Shall while if it's 200, it will have 2 times 200. That will be the resistance. So please always remember this. So this gives me 400 minus T1 equals to, and my M1 is what? 200. Did they give me acceleration? Steady speed, okay, I think as we are solving this question, let's try to judge with this because they said what is the force on the 200, 700 and 1000 kg mass at a steady speed of 6 meters per second. So we'll find the force on each of these masses at steady speed of 6 meters per second. And that means that if it's having steady speed of 6 meters per second, that means that the air will be what? The air will be what? Yeah. Some people are not saying it with confidence. So you know that 200 times 0 is going to be what? Yeah. So 400 minus T1. Which means that T1 will be equals to cross the equality sign. 400, shall we? And we know that this is going to, remember that this is in Newton, shall we? So this is going to be in Newton. So please, tension is the opposing force and is especially found on rope or strength. So you need to know that. So let's solve for the second body, which is 700 kg. So I'll say for the 700 kg, I'm no longer focusing on the force. Rather, what I'm focusing on is the object. It's best to focus on the object, the mass. Then you now ask yourself, what are the forces acting on it forward and backward? It's best that way. Yesterday we were focusing on using T1 and it will confuse you. Focus on the object. What are the forces acting forward? What are the forces acting backward? So for 700 kg, I will have the forward force. Let's draw it. I will have so I have 700 kg. So I will have my forward force to be T2. And then my backward force becomes T1. Then I have this thing, which is the resistance. I have 2 Newton per kg. I see it? Yes, that's the resistance. So which means that if I want to judge this now, I'll simply say forward force is T2 minus backward force. This is the backward force. 2 times 700 minus, this is also another backward force, minus T1 is equals to the mass of the system, M2A. Very important. So this will now be T2 minus 1 for Chevy minus T1. What do we get for T1? 400. So once we are using an example, you see it becomes easy. So then M2 is what? 700. And our A is 0, Chevy. So our 700 times 0 is 0. So I have T2 minus 14 minus 400. Minus 1 HME. So that T2 is equal to crossing equality sign. 1800 HME. Very simple. So once you want to remember this, always remember the shortcuts I've given you. It becomes something that you always remember. There is no mistake to it. Just like when we did vector that I told you. Even if the arm will enter this side, don't judge with the vertical, judge with the horizontal. Yes. Before you go home, tomorrow Saturday, we'll be sending you an app. Yes, for all the paid students. So that is app and that app. That app is for our students. It has all the courses we're teaching you, yes. So that when you get home, you still use it to start. Yes. Yes. This man, okay, the name is what is the people that. Yes. If you go to Hausa land, Akada simply means to think. Yes. Yes, that's what Akada means. To think. Yes. So you see that I want to give it to you, listen and be thinking. So as you are reading, you are thinking. Yes. So now let's do for this one, the last one. So we say for 1000 kg, We'll still draw it. Remember how I'm drawing my code. When I'm drawing it is so that there will be no confusion. So when you learn this properly, drawing it or doing anything you are doing to be sure your answer is correct will not be hard. So I'll simply so now, I'll get the forward force, which is F. Then I'll get the backward force, which is P2. Then I'll get this resistance, which is 2 Newton per kg. Now, when I put it together, now I'll remember the top law of Newton. Action minus reaction, forward minus backward force, equals to the mass and the acceleration. So this is now going to be F minus should be 2 into 1000 minus T2. And everything is equal to the mass of this body, M3, times its acceleration. And this will be F minus 2000. Should be? And this one is 1/8 minus 1/8. And below that, A is 0, should be? So equals to 0. So we now do minus 2000 minus 1/8. Minus what? 3. Can I claim this? Okay, sorry, minus F minus 3/8 should be is equals to 0. Which means that if F cross equality sign, yes, so F, this side is going to be F equals to 3,800, and it's going to be in Newton. Remember that this thing now, the 2 Newton is going to be in 2 Newton. Yes, we are multiplying each kg with the number of resistance Newton the extension of 1. So, no, it's not going to be Newton square. See, open your eyes now. See. Chevy, this is the 2 Newton. Chevy, this thing is the same as saying, this unit that I put per kg is simply telling you that for each kg here, there's 2 Newton resistance or 2 Newton friction. So by the time I have 2 Newton, I'm having 2 Newton, 2 kg, sorry, I'm having 2 Newton kg acting in 2 places of the kg. So if I have 1000 of it, I'm now having 2 Newton acting in 1000 places, which is 2 times 1000. I use, for instance, when you want to go buy your fuel, if you come here, they tell you a liter 200 naira. When you calculate, let's say you buy 10 liters and you give them 200 naira times 10, the money you give them is a naira. It's not good. So what this thing is trying to say is that for each kg, 2 Newton resistance or 2 Newton friction. So by the time you have much of it, if you calculate, you now have the total friction, total resistance, which is in Newton. But I'm putting it per kg so that you remember as you are reading. So F is equals to 3,800 Newton. So that means that the force on the 200 kg is 400 Newton. While the force on the 700 kg is what? Yes, that is at steady speed though. Then the force at 1000 kg is 3,800 Newton. I only put this at steady speed of 6 meters per second to confuse you. Yes, this 6 meters per second is to confuse you because no matter what we have steady speed, it will have no effect on the acceleration. Because at steady speed, acceleration is 0. And I've drawn down for you to see it. So it's not confusing. So the next thing they are asking us to find the change in pulling force at constant acceleration of 0.2 meters per second. Digest. Try and copy it fast. Looking at it small, calmly. You see this? Yes. You're looking at it calmly. I think with time it's the same. But once you know these are our shortcuts, there is no problem again. Once you know bring out that mass, the force forward, the force backward, bring out that mass, the force forward, the force backward, you don't have an issue. The issue you have is if you go to that system, you are trying to judge it from that system and you make a mistake. So I can claim this question. We are done with this one. This particular one is remaining this one. And I want us to check something. Do you notice that, do you notice that this is T1, Jimmy? This is T1, is it not good? Yeah. And T1 is found inside T2, Jimmy? Yeah. And T2 is found inside T3, is it not good? Which means that the order of them all this equation is this one. Is it not good? So the equation of the reaction is simply this one, or the system is simply this one, because inside this you have your T1 and you have your T2. But if you make the mistake of trying to find it from here, you might have a confusion now. You will have issues because you will include this thing that is there, still include this, still include it, still. By the time you finish it, you're having plenty things there. So the best principle, the best approach is simply analyzing it one after the other and knowing that what you have here, everything is found inside here. I ask you a question. Okay, so we can now answer the second question. So answer number 2 question. The answer to number 2 question is simply going to be given by what is the equation of the system, which is F minus 2 into 1000 Jimmy minus T2 equals to M3A Jimmy. But the only thing that will change now is that the A will no longer be 0. Because at this point they have given us a constant acceleration, which is 0.2 meters per second square. Anywhere you see constant acceleration can never be 0. Acceleration will be that thing that is easy to you. But if you hear constant velocity, acceleration. Where you never there? How about you not having fun? Don't worry, you're laughing. Your time will come now. Let's see you enter final year, you see the stress and I got now. Even when I'm going 2021. I am sick. So I will simply have F minus 2000 minus 1800 equals my entry is 1000 Jimmy. So the only thing I will change is the acceleration, which is 0.2. So please come for me 1000 to ask.
That's for 1000. Why is that minus C1 not
Minus what?
C1.
Are you just coming now? So you are just coming. You are just coming. Check their notes. Yes. Do you know what I'm doing? Check their notes. Check what we've done so far. But if we take another example, you'll still understand it. See, we said that the approach is simple. Get every mass. Stop looking at the force now. Look at the mass. What is going forward? What is going backward? For that particular mass. Yes. Then if you go to the second mass, what is going forward? What is going backward for that particular mass? For the problem, what is going forward? What is going backward? If you do it this way, you see that by the time you get to the last mass, which is now the one dragging every other thing here, you see that the other forces are inside the body. So check your notes and try to analyze what we've done before you. When we start analyzing example from the beginning, you must understand it. Yes. So this approach that we're using is an approach that can never be wrong and you will never get confused. Yes. So I have 100 and 0.2. 200 is equals to 2 minus 2000 minus 3008. Sorry, minus 1008 is 15,008. I like everybody participating. So this is going to be N equals to and this will be 4,000. So F is equal to 4,000 Newton. That is the change in the pulling force. Okay, see. So if we really want to analyze the change, we know that any change is always seen. We know that anything change is always in the form of delta this, maybe delta F final. Let's say this is F2 minus, or delta F, which is the same as saying F final minus F1, should be something like this. If we really want to analyze it, we can say, okay, the change in the pulling force is going to, because remember that this is the pulling force. Are you aware? And we can say when it is at acceleration of 0. When it is at acceleration of 0, it's 3,800 should be. And when it is at acceleration of 0.2, it's giving me 4,000. See that too? So by the time I minus this, I have just 200 should be. If I really want to analyze it, like to take note of the fact that there is change. Because this thing here is force. This thing here is the force at acceleration 0.2. Are you aware? While this one is the force at acceleration 0. So if I really want to get or to analyze the change, just as they said the change, I will now say when it's at an acceleration of 0.2. I guess when it's at an acceleration of 0, because we know that final minus initial 0 and 0.2 when I have the second one and the first one. So if I do it, whatever I have there is the change. I know it's not confusing. It's not confusing. Why am I teaching you this? Because some of you will solve, you do 4,000 finish. You look at the option, no 4,000. You say, academic that did not teach this one. Yes. So it's important to know that anytime you're talking about change, you always get that mindset of final minus initial. So definitely what I'm expecting of you is to show that this. So that is yes. That's what I expect of you. This is the first acceleration 0.2. This is the first acceleration 0. So the change in the pulling force is simply going to be when the acceleration is at 0 and when the acceleration is at 0.2. That will be the change. Alright, let's take another question. Please, before we move, if you have any confusion, like if you started and you have any confusion, you always ask me, okay, but I believe it's not everybody that has gotten this past question. But for the sake of those that have gotten the past question, we'll be looking at question 1. Please look at example 1 there. You know one thing, some people will buy it, go and keep it. Yes, some people will buy, go and keep it beneath their locker box where they are saving money. Yes, they will keep it there. The day you have 2 weeks to exam, they have lost it. Yes. Even there are some people that if you are teaching, their mind will be telling them, this thing looks simple though. If I pay attention, well, this thing looks like something I can understand, but I'm not ready now. There are people like that. They'll say, before exam, I will not start paying attention. Yes. But the problem with those kind of mindset is that before exam, there will be no time. And as you're doing it on your own, you are cramming. Yes. So that's why some things we are teaching here, you know it. As we are doing it, that's why when you make a mistake, you point it out. Because it's to remind you those things that you're supposed to do. Because nothing is here. The only reason why things are hard because of the distraction that students have. So please let's go to question on page 18. We'll solve it now. Today I told you we are using slides today for the non-medical students too, because they are coming. So they said a 2000 kg car can accelerate from a speed of 10 meters per second. Right here. I said go to page 18. Page 18, I'm missing it. Page 18 and 19. Page 18 and 19. Question 1 there, example 1 there. Then on the part where they wrote tutorial questions, that place, you will see question 2. You see question 2 there. Have you seen it? A certain 2000 kg car can accelerate from rest to 40 meters per second in 8 seconds. Full stop. Find the magnitude of the balance force which must act on the car to cause this acceleration. I do it for me, class. I should repeat the question. But I said a certain 2000 kg car can accelerate from rest to 40 meters per second material. It's about you finishing it like as if it's nothing. There's something about you finish the past question, finish it again. Going to itself is stressing you. Yes. That's how you prepare for the exam. You've done it. It's even stressing you to open it because you are used to it. If you are going through it, it's not lasting. That's the essence. It's not just that you want to buy. Yes. So I said a certain 2000 kg car can accelerate from rest to 40 meters per second in 8 seconds.
Get your goal now.
Yes. A certain 2000 kg car can accelerate from rest to 40 meters per second in 8 seconds. Full stop. They are not asking us to find the magnitude of your balance force. Find the magnitude of your balance force, which must act on the car to cause this acceleration. So solve it from this last work. I'll go around and check. A certain 2000 kg car. Yes, can accelerate from rest to 40 meters per second in 8 seconds. Full stop. Find the magnitude of the balance force, which must act on the car to cause this acceleration. Even there's something we call past question class. You don't expect, that's why we are trying to see. We're in chapter 4 now. We are trying to see before December that we get to chapter 8 of your course, physics. So that by January, we'll start from the beginning. And for that January, before your exam, the time will come when what we're going to be doing is no longer you come to class, we are teaching you like this. What we'll just be doing is solving past questions. Yes. A book we are solving, yes. That is the secret of success. When your seniors tell you, yes, I need to go there, help me, they are not talking about the taught them in class. They are talking about all those things that are done, especially during revision period. Yes. It's in that revision period, back-to-back class. You are finishing the exam, you are coming out to come and do revision for the next day. Those are the things that make them tell you, yes, we helped you. Not only just the class. If it's like a class, most people can read on their own. Yes. So some that question for me, I will go around and check it. Yes. How you doing? So please see, if you are just resuming, so check their notes, so that you really learn how to convert from different units to SI units. Check the notes of dimension. Saturday, when we are doing all those matters, Saturday class will be all about your physics matter and your practicals. So we'll quickly rush the physics matter because I've taught you how to do practicals. So we'll just answer questions that are new here. Then we'll jump into your money solution. I'm coming. You are there, just like your exercise.
Yes, you guys are not get your own passport. Yes, you guys are not in the passport. Get your own for yourself. Yes, you guys.
Okay, my friend, let me see.
Get your own for yourself.
Sure. So you see, it's very easy. What do you want to Yes. Sharp. Yes. Yes. It's very is it good? Go. Sharp. So today is the first thing. And go after this go. Sharp. Are you next? So please, if you are just resuming, please meet your friends. That's why I normally ask for department. So once you see that person tell me the department, you go and meet them to update your notes. Who is in anatomy here? The promises we started. Is it the one? Who else is in anatomy? Yes. The promises we started. So you meet all these people. Is okay, you sit up. Your sister is very sharp. Yes. Yes. Okay. We saw it together. But everybody is getting it. Everybody is getting it. It's getting it for us to solve it. Yes. Remember we said that dynamics can be defined in so many ways, but the actual definition, the true definition of dynamics is simply the study of force causing motion. They will define it as the study of motion with respect to the force causing it, but actually it's the study of force causing motion. You look at the forces around it before analyzing the motion, the movements. So that is what dynamics is all about. Alright, so let's try to solve it together. Give me the parameters here. Give me okay, initial velocity, that is you. Is there? 40. And what is the meter per second, should be? And our T is what? 8 seconds. Wait, see, assuming they gave us this T, for example, to be in hour, what will I do? Okay, times, I will do 8 times 60. Times 60, should be? That is for minutes and for seconds. That is 3,600. What if they gave us this in minutes? I multiply by 6 alone, should be? The beginning. Why I'm saying it because some people don't know. The beginning. So they now ask us, what they ask us to find this question? The balance force F. I will let F naturally, provided they did not tell us about friction, and they did not tell us about two bodies. As if they told us about two bodies, that's when we talk about others of F1, backward force and forward force. Once they did not tell us about forward and backward, our F is just MA. Because I saw somebody using the word we just finished with. We only use that formula when there are two bodies, or when they tell us that there is friction. If it's just one body, no friction, we just use F equals to MA. Very important. And this thing is the same thing as saying V over T. And you know that V over T, this is the same thing as saying change the velocity. So when they give us velocity, just one, we know this. But if they give us more than one velocity, we now check for the initial and the final one. So you see that this is going to be something like saying 40 minus 0, should be? Since we started from there, all over 8. This is my acceleration. Then my M is what? 2000, should be? So when you do 40 divided by 8, so we have 5, and I have 2000. So by the time you multiply, what do you have? So F is equal to 10,000. And it's in Newton, right? Simple. Let's go to the top also. From that, our PDF. No, this time let's use our PDF. Yes. We'll get back to our passwords when we start doing vertical dynamics. Remember, we group dynamics into 3 categories: dynamics of horizontal axis, vertical axis, and anti-plane. That is Z axis. So let's look at number 3 question. Can I get this? Okay. Then read number 3 question. Okay. something like this? Okay, like this, should it? Okay, something like this. What are they asking us? Okay, we should find the acceleration of the system. So we are looking for a shading. Okay.
For you to understand, you have to show your receipts. You understand it's very well. So please, your receipts on your desk. I'll be going around now. And if you're not with your receipts, collect your customer who you transfer or you leave our class. Yes, then bring out your receipts. Of your payment. Well, once I see the receipt, I'll just pass over you. Do not have. Show your receipts.
So please, the importance of the parents called me yesterday about Gloria. The parents is that the student is in medicine. So the parents was telling me about our condition and state, and I understood it. So you see that sometimes what is holding you back is that you don't care, and it looks as if your parents do not care. Because if your parents, for example, call us on phone to talk to us, we will understand. No, it's not anything more than to give you time. You understand? Yes. Because when you come here, maybe we are telling you to play choreography, you just run and leave the class, say you are not playing. It simply shows that you've not seen the importance. But when you see the importance and your parents have to call on your behalf, it's understandable. So you can be learning. So when the girls will talk more, after our discussion, I came to that understanding that yes, things are not really easy for now and all that. So you give her time so she can start coming. So once you know that truly you are here and you know the importance of this tutorial, you can inquire about it. But the issue is money. Let your parents grab the money, call us, yes, talk to us. We'll come to a conclusion and agreement. Understandable that you live in the class and they are not even at home. Some of you take it by lectures. By the time you finish your lectures, notice now, school just started, everybody wants to do whatever they do. But a time will come when you've missed so much, you are not coming to school every day, you are not seeing the lectures that you are seeing. You now be asking yourself, how far? I normally tell you that everyone in this school, instead of you staying at home, go and find work. Yes. In this school, if you are not a tutorial student and your hope is lectures, just go and find work. Yes. Because if you are lectures and time, if you are nothing is going on, you go, nothing is going to go, so you need to go and find work. So you are not wasting your transport. So please, it's important. Now see, we will try to analyze this system. Do you know that if what I'm giving now with what I'm giving, did they give me any mass there? Okay, let's call this M1, let's call this M2, let's call this M3, let's call this M4. With what I'm giving here, remember our principle. Our principle is simply each one over, each one over, each one over. Do you remember? So if I want to even make it easy for myself, I'll just, since it's acceleration, they're asking me of the system. This one contains all these formulas, everything here. But because of the fact that some of you are just coming and I don't want us to run into trouble, let's take all our time. So let me bring out this first mass. If I bring out this first mass, I'll say for M1. If you understand this thing now, doing energy power work will be very easy. It will be smooth. Because when we start doing all those our pulling the rest, the principles will be easy, even in point play that we start to do. Everything in the center of the view, understanding what it is. So for M1 now, what is the forward force? If I bring this my M1, what is the forward force? T1 should be only. Now once I have this is simply the center saying T1 equals to M1 and 8. That is M8. Mass of the first body and its acceleration. Okay.
Negate the account number.
Yes.
Do your transfer and I'll show you your proof. So let's say I show you your proof. Do your own and show you. If you are not ready, I will not spot you. I will not spot you because I did this. You might take the floor of my room.
Do you know how some people do their house sports? The minute you hotspot them, you will learn. Please, Mr. Mother, don't hotspot too. Is that why you say that as maybe that? Yes. But once you hotspot, you will learn. Alright, see. Now for M2, let's analyze M2. Okay. See, this is the mass now, Chevy. Chevy, this mass. We pull it out. What are the forces? It's supposed to be forward and backward, Chevy, but there's no friction here, Chevy, and there's no resistance here. So since there's no friction, there's no resistance. Once it's one body, no friction mentioned, no resistance. It's just that force equals to MA. Now for the second body, Chevy, you see the reason why I had to take my time and analyze this. And we are using this one. Because actually we start to insist on using total system, we will have issues. Yes, so let's reason it this way. So for M2 now, let's bring it out. M2. Let's get the forward, let's get the backward. The forward is T2. The backward is T1. So in this case, when I have forward minus backward, equals to M3. So I have T2 minus T1 equals to M2A. Are you seeing it? And if I want to make T2 subject of the formula here, I will now have that this is going to be same as T2 equals to M2A plus T1. Hope you understand it. Now for C3, this one, let me break it up for M3. I'll simply bring out the mass M3, the forward, the backward. Now the backward is T2, the forward is T3. So I'll now do forward minus backward equals to M3. So I'll have C3 minus C2 equals to M3A. I'm making T3 subject of the formula. I will have that this is going to be set as T3 equals to M3A plus C2. Hope you understand it. Yes. Now for this one, the fourth mass. Remember, we're always looking at the mass now. Let me break it out. So can I claim this? You copied it, right? Snap it, copy it. Yes. Even if you're in the group set, that's the profile picture. Yes. So for M4, I'll have the mass, which is M4, then I have this, then I have this. So whatever is up, because the back, whatever is there because it's fall, because gravity wants it to come back. So I have W, then I have T, so forward minus backward, using the top law of Newton, actual reaction. So I have W minus T3 equals to the mass M4 and this acceleration. And notice, this W is the same as mg, hope you know. And the mass here is simply M4, sorry. So M4G minus T3 is equals to M4A. Shall we? Now notice, if I want to make this one subject of the formula, I can do it too. It will simply become, let's say, M4G. From this. M4G equals to M4A plus T3. Shall we? But the reason I'm not making this subject of the formula is because of the fact that what I want to get is simply the acceleration of the system. And notice that the last point, at that last point, you don't know the acceleration. At that last point, nobody knows the acceleration. It was not given. But I know this one because mass, whatever mass I'm giving, there's gravity. Gravity is constant. And by the time I saw 14, looking at the question of the source so far, we will get an answer because inside T3 we have T2. We may have T1. Analyze all these things. Yes. So for that reason, this is not what I will make subject of the formula. Rather, I will choose to make A subject of the formula. So by the time I make A subject of the formula, I should have divide both sides by the coefficient of A, which is M4. Is it not true? M4, M4. Hope you know that this thing is the same as that LCM being M4. And what I'm putting it separately. So divided by M4. This will take care of this. and this will take care of this. Okay, I saying it. So that I have G minus T3 all over M4 is equals to 8. So whatever value I have, and remember that T3 is equals to something. Is it not true? I can still replace it. I can say G minus M3A, shall we? Plus T2 divided by M4 is equals to 8. So it's not hard. It's not hard. So all these things I did here is just for us to see how we are getting it. On a normal, I could have just said, rush to the last one, do the weight and the forward, then if I do it, I just get this thing. But we analyze this so that you understand it. It's not hard. Once you understand forward minus backward equals to mass and acceleration. So the next question. If it's confusing, you call my attention. If it's confusing, you call my attention. Page 18. Page 19. Okay, Dr. Shebi, don't worry, we've not gotten there now. Okay, you've first to look at how we solve it there, and you're trying to solve it yourself. Don't worry, when we start doing dynamics on y-axis, we'll check. Yes. For now, we are still on horizontal axis. And how do we know it's acting on horizontal axis? Once you notice that the movement is on the plane, on the x-axis. So notice that this is more like a combination of horizontal and y-axis, showing. But the only difference is that this one has more of the horizontal axis. So that is why we are not going to be using the principles of vertical dynamics here. So once we are done with the question, we'll start vertical dynamics. So read the next one. Read. From our PDF. Once we start from vertical, we'll complete the questions. Can I tell you? No. But I hope this one is understandable. Okay, you got confused from here. From here. But let me do what I think there's a step that is making you get confused. If I have M4G minus T3 equals to M4A, then I want to make a circle of the formula. We say divide both sides by the coefficient of A, which is M4. Is it not true? Shall we? If I divide this, A will be the same as saying M4G minus T3 over M4. Is it not true? I can leave my answer like this. But if I really want to show that yes, I'm trying to solve to get an answer, I'll say that since this is this way, it's the second I say that A is equals to M4G over M4 minus T3 over M4. Because if you do this, if I ask you what is the LCM here, the term is M4, shall we? M4 divided by M4, 1 times this, M4G minus, divided by M4, 1 minus T3, shall we? Which is the same thing. So that's why I just separated it so that now M4 can take care of M4. So I'm left with A equals to G minus T3 and very simple. Very simple. Alright, read the next one. Read the next one. The body of mass, eh? 44 kg, eh? Notice something. Constant acceleration should be. They do not say constant velocity, right? So whatever I'm giving as acceleration, I will use it. Right, go ahead. Wait, the body of mass was 4 kg. So what will be the resultant force on the body? When it hits with a uniform of 60 meters, 16 meters per second. If with this thing, once you forget it or once they are able to get you with this thing, you fail. So you see that uniform velocity, no matter the value they give me, so far as it's something that will have to, or should I say that will have me putting acceleration somewhere, you will be able to see. But they will not show you. So you have to master it. So see, let's start with this one. F for this first one now. F is simply the equals to F actually. So that I have F equals to 44 times 3. Uniform acceleration, whatever value they give you for you to use it. But if you're taking uniform velocity, no matter the value, the acceleration will be zero. Because inside acceleration you have velocity. And if the velocity is uniform, it means it's like this. It's not accelerating under the equation of motion. That, it's like this. So this one plus 4 times 3 is what? 132 you need to share. Now the second one, they now tell us that we should calculate the force. And we know that force is mk, shall we? And in this case, it's at uniform velocity, which means that at uniform velocity, please write it somewhere. You can say note, at uniform velocity, acceleration is zero. You can say at uniform velocity slash steady slash constant velocity, acceleration is zero. So that means that I will have F equals to 44 times 0, which means that the F here will be nothing, 0. There is no force here. Yes. 0. So there is no force here. Yes. So 44 times 0, because the velocity is a uniform velocity. So read question what now? Question 5. Okay. The power of mass. A power of what? Mass 550 kg. Forward acceleration. Okay. The constant resistive force. I see. Constant resistive force means opposing motion, friction. So I can say minus F equals what? 600 Newton. Okay. What they ask me is to calculate the forward force. I see it. So go ahead.
That resistive force is frictional force, right?
Yes. Anything that the tell is opposing the normal force or opposing the motion. So far as the value you're giving is in Newton, you know that it's your friction. But if they give it to you maybe in 2 Newton per kg, or they give it to you in per something, you will not ask what is the total whatever you are giving. Then you multiply it with that particular resistive force given to you. So if they just give you resistive force, know that it's talking about friction. So it's a negative F. And by the time you get this F solid of formula, you just minus 600. So see how we do it now. Instead, in case, in fact, if you are doing anything that has to do with motion and dynamics, even if you don't come and start drawing it, in your mind you have a picture of it. So if this is the body, 550, that's why I started with diagram. Now they are asking me what is the forward force, and they gave me the frictional force. Is it not good? They gave me Fr to be 600 Newton, and they gave me that acceleration on this body, and there is 8 equals 8 meters per second square. What I've asked myself is the diagram of dynamics. That anytime I have friction, the formula to use for force becomes forward minus backward. Is it not good? So it's best to analyze it this way. And I need a little bit you might forget. So once you put it down, you might say this is your F. So you will do the forward force, which you don't know, minus the backward force. And the backward force given is 600 actually. Equals to M8. And this is your M550. Then A is what?
8.
8. So forward minus backward, which is FR, equals MA. Very important. Always analyze it. When we started, I gave you the formulas for this. So it's not every time that F is equals to MA. Force is only equals to MA when you have just one body and when there is no friction. That's when force is equals to MA. Once there is friction, force becomes the forward minus that friction equals to MA. If there are two bodies, you are now judging the first body will be equals to MA. The second body will be equals to each forward force and the backward force equals to MA. So this is now going to be set and say F. I have for me. 550 times 8. You are the one that will be doing the punching. So by the time this equals equality sign, F will be equals to 400 plus 600 GB, which will be equals to what? 5,000. So 5,000 Newton. So please, if there's something you take away from this class, let me take away be that once it's dynamics, that before you think of the motion, dynamics is looking at what are the forces causing that motion. So before you start to think of the motion or whatever they're giving you, analyze it in the diagram form so that you can be able to get the forces here. That's what dynamics is all about. When we start doing the climb play soon, you understand that. Okay, so see, copy this. I don't know if we are free, if we've gotten to the age of me entering dynamics of vertical axis. Okay, what? Give me. I am number 8. Okay, so wait, calm down. A particle of mass 0.4 kg. Okay, so related to two forces. Two forces. That is F1 and F2, shall we? And then not say it's friction. Let's say it's friction. Just two forces. One give it for F1. Okay, if it is a vector. Okay, 2I plus. Okay. 4J. But what about this one?
And F is equals to minus 2.6I.
2.6I.
Plus 8J.
Plus 8J. Okay, all in Newton.
If the particle starts from rest, I don't know.
Okay, wait, if the particle starts from rest, that means that there is initial velocity which is 0.
And T is equals to 0.
And T at that point is 0.
Find its position and velocity at T equals to 1.
Wait, find its position. Position means displacement.
And velocity.
And velocity.
At T equals to 1.6.
Okay,
When T is 1.6.
we can see 1.6 seconds. Okay. Is that all? Alright. So please, should we see how we analyze this question? Once they tell you the length, find position, find distance. Everything they're asking you, when we started this one, I told you that distance and displacement, they are brothers. Just that displacement is, should I say, distance that has direction. So you need to know it. So any question they are asking you in physics, once you start doing, in fact, what is obtainable in reality is displacement. Distance is like a mind thing that you know that from here to here. But in obtainable, once motion starts happening, it's very hard for you to be moving and there will be no change or no shift in movement. Yes. Even when I taught you kinematics, we said that. Alright, let's now try to solve this question. So since this question is given to me in IJ components, it's not like a question given to me in normal plane, maybe on X plane. They gave it to me in X and vertical. What I will first do is ask myself, the two forces, I need to get the sum. I need to get the sum of the two forces. Because what this thing means is that I have force here. Let's say this is my F1. Let's say this is my F1, and I have also F2, and I have also F2. So on the x-axis, I have I means x, should you know? So I have 2I, and I have minus 2.6I. I see it. Then on the y-axis, I have minus 4J, maybe. Then I have 8J. I see it? Yes. So what I have to do is simply, since the forces are in the situation of this way and this way, different components, I will add up the forces on the y-axis and the forces on the x-axis. So that I get total force on the x-axis, total force on the y-axis. Alright, so please, try to sum this thing up. Try to sum this up for me. What do we have? So for x-axis, what are the forces we have on the x-axis? Minus 0.6. Now we know it's I, should be. What about this one? Okay, we have everything here to be 4J. Should be? Now the next thing they're asking us there is that, first of all, we know that force is equal to MA, should be? So there are two ways I can solve this. At this point, I can actually get the resultants. So that I solve this up using Pythagoras. But before I do that, I have to first of all get its position on x-axis, its position on y-axis. Then get it. Reason why am I doing that? Because they gave me this force, So they gave me in I and J. So I need to find that position they're asking me in x-axis. Find it in y-axis. Find the velocity they're asking me in x-axis. Find it in y-axis. Assuming they want me to just find it on one plane, they will just give me the question command. So when I find it in those two axes, that is when I can now go back and maybe do additional by saying, let me find the resultant of everything and let it be 1. So I have to show the position. Since they gave me the forces in x and y, I have to show the positions in x and y, the velocity in x and y. So analyzing this now, I'll simply have F now is equal to F. So now I have my F in y-axis is minus 0.6, shall in I plus 4J, right? Now notice something. I will not use plus because I'm not adding it up. Let me just use comma to show that this is I, this is J. I've not started doing the resultant. I want to first of all find the same one I have the force in I, have it in J in X. Let me find the position in I, find it in J. Find the velocity in I, find it in J before I now add up. It's very important. So is equals to MA. And they gave me that my mass is what? 0.4. Do you know some people, this thing I'm doing now, because they've done vector, once they come here, they find the result and take it and do together. They will not get it in X, they will not get it in Y. You might end up losing Y. Since the forces are in X and Y, find the positions in X and Y, find the velocity in X and Y before adding it up to do the resultant. Alright, so I now have this equals to MA. To make the side of the formula, I can say divide both sides by 0.4. Hope you know. Let's divide by 0.4, which means that this 0.4 will divide the x-axis, divide the y-axis. So one sheet for me, what do we have as our velocity, as an acceleration? So this will cancel this. So minus 0.6 divided by 0.4. Minus 0 what? Minus punch, use your calculator. Minus 1.5, should be? And it's going to be in R. Do you remember? Then 4 divided by 0.4. Eh? 10. Okay, 10J. 10J. Very important. So notice that what I've gotten here is that I've gotten acceleration. I've gotten, it's not like saying, let me just finish this part. It's not like saying my acceleration in x-axis is minus 1.5 r. And my acceleration in y-axis is equal to 10J. I have to get everything in I and J before getting it together. I have to get in I and in J. Is it confusing? See, force is equal to FA, shall this 0.6, we added it. Do you remember? We added all the forces on the I-axis and on the J-axis. And we got this one to 0.6 I, we got this one to 4J. Then we know that force is equal to MA now. Is it not good? And so we are doing, it's more like saying I bring out F. Now I say MA on X-axis first of all. Now let's do that force on X-axis will be minus 0.6 should be and equals to MAX. By the time you divide with this M, and the M is what? 0.4 should be? If you do 0.4, 0.4. I think your parents will always like the short cuts. If you do this, you will see that everything you have here will give you that minus 1.5. Is it not true? And it's in I. So we've gotten our acceleration in the x-axis. It's not that I did it together. Now to get our acceleration on the y-axis, I will do MA1, which is the same thing. So by the time I do on the y-axis, I have 4J for the force equals to 0.4, the mass of the object. So the AY, I don't know, so I divide both sides by 0.4. Divide by 0.4. So by the time you divide this, you see that AY will still give you that 10 and it's in J. So it's the same thing. So what I did is to find acceleration. Since I have force on the x-axis, have force on the y-axis, I'm getting acceleration on the x-axis, getting acceleration on the y-axis. The minute I'm through with that, I see if I can get position, displacement in x-axis, y-axis. See if I can get the velocity in x-axis, y-axis. When I'm through with doing this, that's where I can now say, okay, let me now find the result, let me now find the resultants. But if you rush and find the resultant without getting it in those positions, you are now going against the fact that they gave you a force in the x and y-axis. So you need to find each one of the x and y-axis. Which means it's important that once the question is given to you, and you are being given force on a particular axis, and you are being asked to find anything, find it on both axes before doing whatever resultant you're doing. Alright. Yes. So can I claim? Please, all these little things I normally tell you when we are doing the question. That's where the question, or that's where it matters most. That's the part that matters most. Because once you forget it and go to do the final part, because the film is very easy. At the end of the day, you come to the option and you will see the position in I and in J. But your answer is not there, and you will not remember. So please, always remember about it. So we've gotten acceleration in the y-axis, acceleration in the x-axis. So the next thing is to see if we can find position, displacement in the x-axis and in the y-axis. Questions can come in. If you have questions, feel free to ask. This our class is not a class of display or abracadabra. If you've noticed, most of the times it's as if we are solving together. So ask. Is it this one? Okay, this one. Yes, this one means 2 in the x-axis, 4 minus 4 in the y-axis, 2.6 in the x-axis, and this one is 8 in the y-axis. Yes, how I got the minus 0.6 is simply saying taking the 2 in the y-axis for the first one, and taking the minus 2.6 in the first 2, in the y-axis, in the first 2. Adding the 2 of them together gave us this. And then taking the 4 minus 4j in first 1, that is the y-axis, and taking the 8j in first 2 here. So by the time you add it up, so we are adding the total forces. Once you are giving force and you are told that the forces are not in different directions, then what you do to the net force is that you add up. I see it, yes. If you are not told that it's a frictional force, you are not told that it's a frictional force, just like what this one will be doing. You are told that you have a force and you have another force. And those forces, they do not tell you it's a frictional force or it's going against or it's a resistance or whatever. To get the next force is simply by adding it up. So that is how I got the force on the x-axis. By adding the force on the x-axis for the first 1, force on the x-axis for the first 2. Then adding force on the y-axis for the first 1, force on the y-axis for the first 2. Adding it up. Once you add it up, the next thing you have to do now is to simply remember that you are now having y and x-axis force. The same way you will also get acceleration for the x and y axis, get displacement for the x and y axis, get velocity for the x and y axis. Then you can now go on your own to show that you understand vector very well. That's why you did vector studies and now do putting them in the x and y coordinates then to find the total whatever it is. So you can now find the total force, you can now find the total displacement, you can now find the total velocity. Isn't that what I have? Come on, you do it. Yes. So our AX, yes. On the x-axis, AX is equals to minus 1.5. So please let me explain this. You will still give it to me, all these things, so that we don't get confused as we are going through this process. So what we did for force on x-axis, we did F equals to MAX, and we use the force on that x-axis to put it against the mass and against the acceleration. Making acceleration on x-axis solid of formula we got minus 1.5. And making acceleration on the y-axis solid of formula we divided by 0.5, we got 10 g. So we got the acceleration on x and y-axis. Now let's get displacements on x and displacement on y-axis. Please, you see all these things we are doing. Once you are remembering the approach, the formulas, there's nothing on any part of this world that will make you see a question under dynamics and you feel scared. Because what we are trying to touch is all the different things you should know. And that's the goal of this class. So once you see a question, the forces are not telling you resistance. How to get the forces, the net forces is to add up. And that is what I did. The two forces, I added up. And notice that this is x-axis, should be. So the total force on x-axis, that is what I got by adding up. Then this is y-axis. The total force on x-axis or y-axis. Alright, so let's look at position. They said position. And position means displacement. So remember that we have equations of motion. Remember that dynamics is the study of force causing motion. Or I said the study of motion with respect to the force causing it. But I normally tell my students that the proper definition should be the study of force causing motion. You have to first of all find the force before talking about the motion. If you find the motion before the force, you might go wrong. So I will now say in the equations of motion, I have something like S equals to ut plus half at squared. Do you still remember? And notice that since what we are dealing with here is not gravity, my A remains my A. Is it okay? And since they did not tell me that something went up, I will not change this to minus. So it remains plus. My equation becomes my equation. In fact, anytime they ask you to find the position of something, the displacement of something, the first equation I want you to think of is this one. While anytime they ask you to find the time for something, if it's projectile, you think of this, the total time. But if it's time for when something happens, you now remember that there's something like v equals to u plus 8. Should it? You can make this one separate on the formula. And remember we also have v squared equals to u squared. So this thing can also mean height. So when you are doing that projector, you want to find maximum height. So here we normally do it. We've done projector, we still repeat it. But not now. So let's not try to analyze this. That question says something about at rest, should it? Read the question again. Okay, see how we go about it. We want to find the position at x-axis, which means at x-axis this will always also be ax, should it? And when we want to find for y, it will be position at y. Do you understand? So now read the question. Everybody, 1, 2, ready, go. What if it did not start from origin? If it did at rest, what they are going to tell you is a particle moving with a velocity of. That means your initial velocity will not be that velocity given. You see it? Anytime, even analyzing what we do in kinematics, if a question gives you a body is moving with a velocity of, that is because the initial velocity. Yes. But once I did not say that they tell you is at rest, that means your velocity initial will be zero. Let's do it. So since this one is at initial, that means u will be zero. Should it? Times 1.6 times t. 0 times anything. 0. Then I have sx equals to. Then this times this becomes at squared times axt squared all over 2. And this anything final on this one, this can do cross over. So that I have, or let me just use it since its position and stay primary. So let's not cross anything. So xx is equals to my acceleration of x-axis is what? Minus 1.5. Then the time given is 1.6. Then all over 2. You are behind this thing now. Once you punch this, whatever I give you gives you is the position of x-axis. I see it. It's not hard. The only place it will be hard is if you are giving force in x-axis, giving force in y-axis, the take to find position. And instead of finding the position in x-axis and y-axis, finding whatever the next in x-axis and y-axis, you want to go and do vector, do a resultant first to enter problem. So punch for me. 1.6 squared times minus 1.5 divided by 2. Everybody, what do we have? Minus. So if you go there, roll everything on here. Do for me 1.6 squared first. Times it with minus 1.5. Divide by 2. What do you have? Minus 1.92. Like this. In meter here, right? So this is approximately minus 2 meters on the x-axis. So sx. So displacement of position at the x-axis is at minus 2 meters. Alright, let's find for position of y-axis or position of the body at y-axis. So I will now change this to sy. Very simple. Can I clear? So for sy, I'll have ut plus half ayt and to be squared. So sy 0 times t, everything here will get out. So I have equals to ay c squared over 2. So acceleration of y-axis is what? 10. 1.6 squared all over 2. I thought it from 1 year. So 12.8. So in meter. I know that the unit of displacement is meter. Very simple. Very, very simple. Now so you see here, what this thing simply means is that if, for example, as I'm here now, I've gotten displacement of x-axis, displacement of y-axis. If let's say I have to find the total displacement, I can now bring this. Let's do our vector now. This is the y-axis, 12.8. Is it not good? This is minus 2. Shall we? So to get the total displacement now, we simply this one becomes r. I see it. So I can now do r squared equals to that s squared minus 2 squared plus 12.8 squared. Here we know already becomes the total displacement here because you still take the square root of both sides. Is it not good? This will cancel this. So once you finish, whatever it gives you now becomes the total displacement for this. The same thing with when I did acceleration. For acceleration, I come and do the acceleration this way and the acceleration this way. Whatever it gives you becomes this. So, but the most important thing once the question is asked and you are given force in x and y axis is to find any other thing they are asking you in x and y axis. Very important. It's now up to you to do the extra work of finding the total resultants. So, but the key thing is finding the some x and y axis. Alright, so let's find the velocity. They ask us for velocity. So we'll find the velocity at x axis and the velocity at the y axis. I want to play. So the extra work you can be doing for this, just as you got in the acceleration, find the total acceleration on the, that is the resultant acceleration. Find the resultant displacement. So when we get velocity, you find the resultant velocity. Should we understand it? Yes, the one here, the one here. But us, we are finding x and y for each one because they gave us first with x and y. Very important. Very important to remember this thing as I'm saying it. Because in the example, time is very important. Most of the time you know everything in that example. But because you did not practice, you will see one question. You will not be thinking what they gave you there is too big for the time. Yes. You will be thinking instead of writing the question. You will be thinking. So they expect you to solve all these things in this time. Alright, let's find the velocity. So velocity, first of all, we know that velocity is equal to displacement over time. You see that? Should we? You can take it. And we know that velocity also is equal to, first of all, we know that acceleration is equal to velocity over time. Do you remember? Yeah, don't worry. When I grow up, I will start doing that one. For now, I'm an African man. Yes. When I grow into Western man, we'll be doing all those phonetics. Now see, acceleration is equal to velocity over time, should we? And velocity is equal to displacement over time, right? Yes. Now we need to check something. If you remember when we started this, there is a velocity. I will find, first of all, derive our acceleration on the x and the y axis. Is it okay? And if that be the case, it simply means that if I make this sort of formula, I can get my velocity. So that I now have v is equal to a times t, shall we? And I can have v equals to ay times t. Very important. Somebody will want to ask me, but why are you not using this one? Why is it this one you want to use? You are never daily magic. Yes. So they must question it. The reason is like when you start, if you're an engineering student, there's what we call derivative to derive something twice or to derive it once. If I use the time given to me for something to get a particular solution, if I use it again, I'm deriving it 2 times. So notice that to get this displacement, Shebin, I already used this time. Is it not true? I already used this time of 1.6. Do you remember? Then, yes, now see, to get this displacement of y-axis, I give 10 a1 times t. Is it not true? Divided by 2. But remember that when I got my acceleration, I simply did that particular force over the mass. Is it not true? So these two things, they have time in common. They have time. This one have time, this one have time, should be. But I've already used the time when I derive this displacement. So if I come and do this displacement that I've gotten, and still divide it with the time they gave, so I'm deriving it 2 times. So that is why I'm avoiding using this formula. That's why I'm not going to use this formula. So I will simply use this particular one, which is that acceleration I've gotten, then times the time. I say it. So by the time I multiply the 2, I will now get the velocity in x-axis, which is so notice that I've not solved anything. When I derive the acceleration, remember, see what I'm saying. In this question now, whether you like it or not, for us to get the velocity in this question, time must be used. Yes. But that's the longer process. So because us trying to do because we've already passed to that stage. So what I'm saying is, in these 2 formulas that we know now, what we are using is actually A equals to V over T, making this center of food. Reason being that T, which is 1.6, must be put to use. And the T, which is 1.6, when we derive displacement, we already use it to derive our displacement. Is it not good? Yes. So if I still come and put that displacement again, over the same time that I used to get it, it simply means that I'm cancelling out the displacements there. That is, I'm cancelling out the time in that displacement. So what I'm going to get in this question, if I use this, using this displacement that I've got over time, is more than me going back to get acceleration. I say it, so that is why I'm not using this. I'm using this. So but if it becomes a problem for you, you can use the equation of motion.
When you plan on going to use this one.
Yes. So this is going to be, see what I mean? Vx here, this is Vy, sorry. Vx will simply be equal to, give me what you have for acceleration of the x-axis. Minus 1.5, let's do this. Then times 1.6 should be, or you punch it for me. 3 point what? You go do what's the minus 2.4. Minus 2.4. Meter per second, Chevy. Please, the importance of using your calculator to solve certain things is that there are some questions when you punch it in your mind is correct. But the minute another person look at it, they will see that it's not correct. So always make use of that your calculator because it's important. Now for Vy, I will have acceleration of y-axis is what? 10. Then Chevy? Then times 1.6. 16. So we have 16 meter per second. And notice that it's on the y-axis. So when we are doing y, we say Vy equals to AYC. Hope we're understanding this thing.
Yes.
Are we understanding this thing? Please, if you are late, come and you just enter. Check their notes. Give space. So that once we now start doing vertical dynamics, it will not be hard. I just try to open up my teeth one day. For the position, remember that we got position at x-axis. And we got the position at x-axis. What do we get position at x-axis as? Minus 2, shall we? And that is on the y-axis, we have 12.8. The position at y-axis. Yes. So now see, what we are not saying is to find the resultant position. To find the resultant position now will be you using Pythagoras. So you are the one doing that one for me. So since we've gotten the position at x-axis, the position at y-axis, because our force is in x and y-axis, then we can even do our force also to find the resultant force of what. So you now your segment now, or the other software is to go and get me the position of the resultant using Pythagoras. What is on x squared plus what is on y squared? Take the square root. The same way as we've gotten the velocity now. See what I mean? I have my velocity now on the x-axis to be minus 2.4, on the y-axis to be 16. So to get the resultant position, the resultant velocity which will be here, I will simply do, I will analyze what we normally use this Pythagoras. I have squared equals to minus 2.4 squared plus 16 squared. Yes. So please, punch this thing for me. Let's punch minus 2.4 squared for me. 5.76 plus 16 squared. 256. So we have squared. So taking square root of both sides. 16.17. And this will be in meter per second. So 16.17 or 16 meter per second. So please, what I'm saying is, we are getting on the x and y axis. Your assignment for each of these things is gotten. For displacement, get me the resultant. For velocity, we've gotten the resultant. For acceleration, get me the resultant. For force, get me the resultant. So now that we finish solving this, the next thing we need to do is to represent it. To present our answer. Yes. If you do, see, if you see the same thing you will get now. See, somebody is asking me if I do V equals to U plus AT, it's the same thing. Is it not the same thing? Because I know that at initial, they told me that I have an initial velocity which is 0, right? So if I do 0 here, so this one, let's say this one is x. If I have 0 plus, so you see that this thing will get out. So I just have my A, C. And if I'm doing for x-axis, acceleration on x-axis, it's the same thing we use here. You see that too? And if you're doing for y, this now will change to y, this one will change to y. It's the same thing. But I'm telling you, the reason why we are using this one, and even doing when we make acceleration subject of the formula, the reason why this thing is possible for us, and we are not doing v equals to s over t, is because the s that we got was gotten using that 70, which is 1.6 shilling. And we know that if we want to use that displacement over time, the time there, the only time there is that 1.6. So if we do that displacement over that same time, we are deriving twice. So it's not possible. So by all ramification, the only formula we should use for V is this one, or when we make our A subject of the formula from this. So that is it. So please, I want to believe that this thing is not hard. Shall we see it's not hard? Yes. Okay. See, that's why when I started this talk, I was stressing on doing for x and y. See our question. As soon as we started, they gave us force on x and y as it should be. And we then rush and then make that force subject to be one force. That is the resultant force. And that is total force. You will see that with that total force, anything we are going to be getting will simply be more like an answer when you've gotten the other ones to be in total. That is maybe the displacement now, when you get the resultant of it in total. So but for us to be able to get this in the x and this in the x, y, we have to use the force given to us in x to get what is in the x for maybe acceleration. We use this one for y. The minute you make the resultant, then everything you will be getting with that same idea will no longer be going to x and y. It's just giving you a total value, yes. That is why I said solve for the x, solve for the y for each cases, then find the resultant for each cases. That is what you are expected to do once your force is in x and y axis. Then when you are finished, you need to present your answer. Let me print it so that we present our answer. So remember they asked us to find position in that question, shall we? So for my position now, my S is going to simply be, I got, what did I get as my S position? Minus 2. In meter, shall we? Then what did I get for the Y position? What? 12.8, right? J. And everything here is in meter. So this is my position. This is how I present it. Now for my velocity, my V. What did I get as my V in x-axis? Minus 2.4 R. Then what did I get as my V in y-axis? 16 J. And I know that the unit is meter per second. Shall we? Yes. And my acceleration, they did not ask me acceleration. Shall we? I only got acceleration because for me to solve every of these things, the only way it can be possible is by me getting acceleration. That's why I solve acceleration on x and y axis. So why are we looking for? There's no need, right? Yes. But when we are doing it, see, when we are doing it is so that as the students, a question can come, it's no longer this one we are solving. They now ask you, find the resultant displacement or find the resultant position. The question can come that then you find the resultant velocity. You will see that if you come and solve this thing now as your resultant velocity, you will be wrong. Are you seeing it? Yes. So that's why as a student, when we do the one we have, we still go for that to make a research and do the rest. Yes. So please, make sure you find me the resultant acceleration. Then make sure you find the resultant displacement. Then make sure you find the resultant velocity. Yes. So I want, the truth is that dynamics is very simple. That's the truth. So once we are through with dynamics, we now start to enter our serious work, which is says that work, energy, and power. Conservation of linear momentum, moment, equilibrium of forces. This is where we are now entering into things that matter. Are you seeing it? So please, let's quickly write as a sub-heading. Dynamics on vertical axis. So we say vertical dynamics. So dynamics on y-axis, so we say vertical dynamics. Dynamics on y-axis, so we say vertical dynamics. Why I'm doing this for this, so that once you see a question that revolves around horizontal dynamics, you should know. Once they start telling you a body is lifted up, they are drawing water from where? They are throwing smoke from down, and they are telling you that there is force around it. You know that but they tell you, a man enters an elevator, the elevator is carrying him up or is carrying him down. So far something is going up or down. This type of person, the force is here. That means it's dynamics on vertical axis. Alright. So please write dynamics on vertical axis. Dynamics on vertical axis, or we say on y-axis, is the study of force dynamics on vertical axis, or we say for vertical dynamics, or dynamics on y-axis, is the study of force acting on a body in motion. Acting on a body in motion. It's the study of force acting on a body in motion due to gravity. Vertical dynamics or dynamics in y-axis is the study of force acting on a body in motion due to gravity. Alright, so the first principle I want us to get, I'm so happy for Friday, this Friday, because I'm seeing the possibility of us finishing our dynamics today. So that tomorrow, all we'll be doing tomorrow is just practical and your manual. Tomorrow we'll solve a lot of manuals. Now see, if I have, for example, this to be a body, see, please, if this is a body, I know that naturally anybody on this phone, upward is normal reaction. Why downward is gravity, shall but whenever you want to talk about this gravity, don't just write G. It's actually weight. And weight is equal to M. Are you seeing it? Yes. You need to always analyze it this way. This is what we call force. But the force acting on the body upward is called normal reaction. While the one acting on you downward is called weight. So if I know this, naturally when this body is at rest, there will be no acceleration, should be? Is it not true? Which means that naturally everybody that is at rest has something of normal reaction going up and downwards. But the reason why there will be equal is that even if I do n minus w or w minus n, everything will be equal to n. Do you still remember force? So that I told you these are the forces acting on this body vertically. The one going up and the one going down. So let's say I have this. It has some tendency, let it go up more. That means this because the forward force, this one because the backward, right? And in case where it really wants to go down, this one because the forward force, this one because the backward. But because it's at rest, as we just said, the A will be same. The A will be same. And anything multiplied by zero is equals to what? Zero. So everything equals to zero. Everything equals to zero. So whichever way you do it, you see that it will be equal. Because if this cross equality sign, you now have that n is equals to w, shall we? And if this one cross equality sign, you now have that w is equals to n. Are you saying it? Yes. So for a body at rest, For body at whichever way you want to put it, forward force minus backward force will be equal to 0, which means that forward force will be equal to backward force. So forward force minus backward force equals to 0. In fact, once we are dealing with dynamics, or you get to the part of Newton's law, your mind should just be telling you forward minus backward, forward minus backward. The one that is active higher is forward, the one lesser is backward. So you say that forward is this backward crossover. Forward force is equals to backward force. Very simple. Very simple. Now, let's say a body is being dragged up or thrown up. So, for a body upward, or let's say somebody enters an elevator, the elevator is carrying the person up. So, for body moving upwards, for body accelerating or moving upwards, for body accelerating or body accelerating upwards. I have a reason why I'm using accelerating and not moving, because we need to know the term. So we know that acceleration is active here, upwards. This is not like when we did projectile motion, when we told you that if something is going up, no more acceleration, we consider it G shaping. This is why you need to always know that the body, that whatever you are dealing with force, will always be the body in respect to A. So in this case, the normal force acting on the body, any body you see, whether it's moving or authorized, the normal reaction is. So if the body is moving upward, which means that the weight normally wants everybody to come down. So for a body to be moving upward, it means that the normal reaction is more than the weight. Is it not the Yes, so normal reaction is being with weight. So weight will be negative. And for that reason, we say that normal reaction is the forward weight. While weight is the backward. And our principle is forward minus backward. Should it equals to M8. So for that reason, I will have, in this case, normal reaction minus weight is equals to M8. And notice something. A is active here because there is movement. Are you seeing it? It's not at rest. So acceleration is active here. It's accelerating. So for the fact that it's accelerating, I will now have that W means mg. Is it not true? So equals to ma. So if this cross equality sign, now that n is equals to ma plus mg. Shall we? M and M, they are common. Is it not true? Two things in common. So another way to write this formula is n equals to m into a plus g. So this becomes your formula for any body going upwards. And notice that g is still a constant. Do you remember? Yes. So copy. So the next one will be for a body going downwards. Sometimes when they tell me I submit to postulated certain laws, like certain laws that I submit to postulated, you will be asking yourself how I wish. Then you were there. Sometimes you can ask yourself, where was my grandfather? You know why? Most of these laws, see what the law do. That law of gravity that I normally say. If you do something come down, you look at it now. It's coming down. You now put it. The body flow will come down. That's law of gravity. Shall you understand it? So if it goes up, it comes down, which is a normal phenomenon. Yes. But guess what? Even till the end of time, your children, there still will be thoughts that this law was postulated by Isaac Newton. Are you understanding what I'm trying to say here? Yes. It's a natural thing. They don't need to go to the laboratory to prove it. And it's getting dark a bit. So it's big. It's big. That's what I'm trying to make. Alright, let's try to look at a body moving downwards. If the body is moving for body, let me use acceleration. I will use acceleration so you know that acceleration will be active. So for body accelerating downwards, want to play this. So for what it was directing downwards, all this is I'm saying, if you check out past what you see is there. So for those of you on a money for something, once they give you the money, do you know that there are students here that collect like school fees 2 times? Yes. There are students here that they will collect first semester money, collect second semester money. They say the school fees they are paying 2 times. There are students like that. Once the conversation they have with their parents lead to, even when the first semester, get one school fees the second semester. You see, mommy, I'm not doing what that's for 8 years now. Not like they will stop that. So second semester, they carry around and do it. Yes. So please, why am I saying this? If they're giving you money for past questions, tutorials, whatever it is, pay it now that you've not eaten the money. Yes. Pay it now. Because the time will come when in your mind you know the tutorial is important, but because you've not paid, because in your mind you feel like the money you are using now is no longer the money they gave you. What will you do? You now start staying in isolation. Yes, you start staying in because you want to live on your own. It's more like 2 pages, you get tired. You're not living again. But yes, you are seated here, whether you want to learn or you don't want to learn, you must learn. That's the importance of this tutorial class. Alright. So for what they're directing downwards, notice something. Think this is his body. I know that naturally everybody you see, even you that you are seated, even as you are seated, there's a force in you that is pulling you upwards. But the one pulling you downwards is more. Wait. That is why I often tell my students, they say that gravity in the moon, if you go to the moon, that gravity there is 1.7. Can you hear me? They say that gravity in the moon is 1.7 meters per second square. Which means that for those of you that when you sit down in your mind to how can I fly? I want to fly. You don't need to be here. You should be in the moon. So maybe if you get to all these planets, maybe, then there's a possibility that one thing can be flying. The same way bird is flying. You understand? Yes. So that simply tells us that gravity on Earth is too much. So that is the reason why I have WG, MG, sorry, W, M, and N. Now analyzing this is coming downwards. It's coming downwards. Now it's the gravity that is pushing it downwards more. You see that normal reaction will be useless. No record. That is why if you watch some news, one time they said a musician, I don't know if police came to arrest him, he jumped from the roof of the building. He jumped from the top tower. He's a friend to Neymar. The story is popular. Neymar that plays football because at that point Neymar posted that story. He jumped from that out there from the small to something story building. He wanted to enter the swimming pool. But he didn't read physics. Yes. Because actually he read physics, you will know that at your point, as he's flying down, he will lose control. Yes. Even as he's trying to stretch, it's no longer him. He's just going. Yes. So that is what happened to him, and he just crashed. And he died. So that means at this point, when that thing is falling down, this will be totally useless. So that means W will start this. W is now the forward force. And this now becomes the backward force. Equals the mass of this body and its acceleration. Alright. Now notice W here is mg, Jimmy. You still remember? Yeah. So if let's say I want this to cross the quality sign and this one come over. You understand that this cross over will not be equals to and this is the same as n equals to mg minus mk. Do you know why I did this thing like this? Most of the time students miss it. You will say student maybe you carry this one come here. You come and put minus on it. Is it not good? Then when you want to cancel, you forget that you should cancel this. So the best approach simply, in order not to confuse yourself or run around before you get to what you're doing, simply, this is mg, weight means mg. Just add this from so that I now have n to be the same as saying m into g minus a. I say this? Yes. So for a body accelerating downwards, this will be the formula you're using. M equals M into G minus the mass. See, if which one cross over? See now, this one crossed over. And it became plus, this one crossed over, it became minus, right? So we now have this to be mg minus ma that crossed over. Then positive. We can try it in other ways, or let's start being divided by. So see, this is my formula. When I start being in that case divided by minus 1. So this is an easy approach to it. So how many formulas have I given you for a body moving upwards and downwards now? Is it 2 or 3? When it's at rest? Should be the eyeball. Then when it's going upwards, we have this. Then when it's going downwards, we have this, right? Yes. Please, we are going to do calculation under this, but before that, ask. Okay, do it how you know. Do it how you know. Do it your own way. Do it how you know. Do it your own way. W minus N equals to MA. Your own way will be that if this cross the quantity sign, you have minus N equals to MA minus MG. 0 to now notice that for the fact that I have minus here, I will say divide both sides by minus 1. Divide both sides by minus 1 is 0 to. So this will cancel this, so that I have M equals to minus MA plus MG is 0 to. Anything plus can start with MG minus MA, which is the same thing. So you can do it your own way with this one. But I did it this way because I like the short cut, the straight to the point. Okay, so please. Why is it W minus N and not N? See, that's what we said now. We said that as it's coming down, naturally, the force acting on the body downwards is where it should be. The one acting upwards is N, should be. When I say, if this thing is thrown down, you see that as it's coming down, the end because the backward force, because it's going this way. This one because it's moving force, naturally. So that is why it's one forward force here. Alright, so please, before we start our calculation on this, I want to quickly treat what we call friction. So that we can now solve all the calculations together. Friction, and then we'll get into what we call inclined plane. So once we get all these formulas, we can solve questions and we'll call it a day for today. So please, right, friction is defined.
Everything you say is in the past.
Friction is defined as the opposing force or resisting force. I said friction.
Okay. You don't read it yourself. Let that do
opposing force or resisting force to motion. Huh? I said it's defined as opposing force or resisting force to motion. Friction. We can also say that friction is the force opposing motion. It's the force opposing motion. Force in the negative direction is known as friction. So there are so many ways you can define it. And we know that naturally we have two major types of friction. Are you aware? Namely, yes. And then for dynamic is kinetic friction. So the friction, now I want to ask you, the question I want to ask you, between static friction and kinetic friction, which one is greater? Yes, the static theory, yes, because it is a general belief that when the body is at rest, before it overcomes that friction to start moving, that it will have more work to do. But the minute it's moving, it doesn't require much. That's why sometimes when a car breaks down, they can call 100 people to push it. It's not the then if they manage to move, even though it's not working very well, it will just be trying. Yes, they'll be telling the man, don't off the connection. Yes. So that is the general question you need to know. Another thing you need to know is that since we talk about kinetic and static friction, this kinetic friction, static friction, is given by what we call the coefficient of static friction and normal reaction. While kinetic friction, I think that static friction is simply the friction possessed by a body at rest. So it's more like, another way to think of it is more like somehow related to potential energy. Yes, there is friction when the object is moving, but when it's at rest, it has more friction. Then we also have another one called the kinetic friction, and it's still the same thing. So coefficient of kinetic friction times the normal reaction, which means that if we want to make coefficient of kinetic friction or static friction subject to over here, we can simply do yes. Is it that true? So that this becomes yes. So is equals F static friction all over normal reaction. And if we do the same thing here, So because kinetic friction all over normal reaction. Check the note. I said it is the friction possessed by a body when it is in motion. So a body moving, if a body is moving, actually, even though that most of the time they don't tell you, is when they don't tell you about the friction of the body, it's more like we are not really telling you of it. But every body that is moving, just like if you are walking now, if there is no friction on you, your body you be able to grab, to hold firm on the ground. Just like if you are more on the movement will not be the same. If you are more on here, it will not be the same. Yes. So you see that in that case, we have reduced the friction. Yes. So the reason why you are able to hold firm on the ground, is because there's friction. That's why if you are walking on a smooth place, let's say your life floor, and there's oil on it, like excess oil, not manageable oil, excess. If you are not careful, you die. Yes, it has happened to some people. Yes, it has happened to a lot of people in this Nigeria. You are entering your bathroom, oil is there, you are not aware. You just sleep, you carry your head and you say, before you know, God, help me. You are done. Yes. It's rare. So that is what kinetic friction is all about. So now that we know this, I want us to use this same concept to get what this N is, because whatever we are going to do in dynamics as regards to friction will center more on our knowledge of what inclined plane is. So that is why quickly we will enter what we call dynamics on Z-axis, or we say inclined plane dynamics. Inclined plane dynamics, or we say dynamics of an inclined plane. So again, you will not be seeing how we make use of this with regards to movement on an inclined plane. So once we are able to do that, we start solving our calculations, and once we have done that, we will come to the way of dynamics. So we can solve more problems, especially from our matter. So see, you know that anything this way or this way is called a Z-axis, surely. It's on a plane, right? And you know that if it's this way, it's Y-axis. If it's this way, it's X-axis. If you come and enter here, come and enter here, come and enter here, come and enter here, it has now become Z-axis on a plane. Is it not true? Yeah. So for that on a plane, I want to use the one that I'm used to, which you are also used to. When we have a plane going this way, you can have it in different direction. You can see your inclined plane in different direction. But we want to start with this one. You master this, you can go forward. Now see, notice that everything around this and everything around this, This is your y-axis, is it not? This is your x-axis, right? That is why sometimes they will come and draw that thing you normally see like a triangle whenever you are putting a inclined plane. They will come and see maybe an object of mass is sliding, maybe somebody is skating, or maybe you are not white person now. But those people they say you are is this snowboarding? Yes. You've never tried it in your life. So yes, but let's just use all those imaginations to understand what this inclined is. So let's say this object is moving down this plane or moving up this plane or is at rest on this plane. You know that when it's at rest, you copy it, yeah. Copy from your friend. So which means I want us to analyze the different cases. So there can be a case where so I can have a situation where this is also moving downwards. Then I can have is it being understood and start coming? Alright, stand please. If you are just entering, check the notes and pay attention. So I can have when this is at rest, when it's not moving. Starting from rest. These are three different cases of inclined plane. So when it's moving upward, moving downwards, when it's at rest. So we start with when it's at rest. So let's say that this is the surface of the earth. Notice everything you see on earth is more like. That's why before the reason you say the world is flat. Yes. So it's more like we have the vertical axis of the earth, the horizontal axis of the earth. Then we have it inclined at a plane. So what we are saying here is that when this body is at rest, so this cage is at rest. That at rest, the friction it will be experiencing here is going to be starting friction. Are you saying this? Yes. So we are trying to compare our inclined plane as we're dealing with inclined plane, or we say dynamics of an inclined plane. What we normally pay attention to mostly when we are treating inclined plane is both the forces and its frictional force. So in this case, we ask ourselves, if this would not come to this, if this is this inclined plane, and I know that there's this object here. If I ask you, at what direction would force of gravity be acting on this object that is inclined here? Remember that force of gravity does not bend. If you say that it will be acting this way, it's no longer force of gravity. Force of gravity acts this way. So force of gravity on this object, on each side of it is vertically. Are you saying it? Now notice, if this object is like this, what is the y-axis? Should be here. So this is this body. Remember we said everybody acting this way is W. Wait, Chevy. So this is the weight on the y-axis, right? Now this is the x-axis, Chevy. Now whatever weight I have here will be weight on x-axis. It's acting downwards, so acting downwards. While I have my ending this way. So once we are treating inclined plane, we are now analyzing our weight on x-axis, weight on y-axis. So now when you turn this thing like this, you see that this part becomes the part where I have my weight on y-axis. You see that way? That is turning it on this side. Chevy? Yes. Now, pay attention. This part, notice this part is the part where I have the weight on x-axis, y-axis, weight on y-axis. There is weight acting on this as it's going downward. So if you want to analyze the weight of the y is this way now, or the x is this way, y is going to be this way, right? Yeah. So that means on this side, I should have weight acting this way, and it's going to be the weight on the x-axis, right? Yes. So at any point, let's say, as we are analyzing this now, let's say this weight now meets this here. So let's say I call this one my W, X weight on X axis. Now notice that we said that gravity itself will always be in this direction. Is it not true? It will always be vertical. You still remember, it's going to be always vertical. So if that is the case, if I have this way as well to be my gravity, and you know that it's G, and there's mass of this body, is it not the mass of this body, which is going to give me M. So I have my mg. Now by the time you analyze what we've been able to achieve here, you see that we've achieved beneath this, we've achieved something of this nature. Down here. We've achieved something that looks like this, under this. Because if you take this now to be y, the weight on y axis, weight on y axis, weight on y axis, weight on y axis, weight on x axis, weight on x axis, weight on x axis, weight on x axis. You see that this becomes my weight on x axis, this becomes my weight on y axis. Then that's our straight line for gravity that accelerates because my mg, that is gravity and its mass. Now, what angle is this object making with this triangle? So many. Only Jesus. Now, see, you see what we are doing here is the reason why most students don't understand inclined plane. But you just need to pay attention now so that it becomes very simple. First thing, I will repeat, see. First thing is this. We need to know that this is the object, right? Is it not true? Let's analyze something. The first acting on the body upwards is a normal reaction, right? The one acting on this object this side, that is this way, is what? Y shaping, weight on Y axis and vertically. Now, the weight that will be acting on this object downwards is going to be what? Weight on X axis, shaping? Yes. And notice that as this body is this way, the gravity wants to act on it is this way, shaping? Now, even if you turn this body, the gravity wants to act on it is still going to be straight down. So that is why I said let's turn this down. If we turn this, we now have this way. So that we now have weight on Y axis, weight on X axis, shaping? Now, gravity wants to act on it, it will still be this way. Straight down. Now, if you analyze it now, if you project, for example, all the weights, let's say we start from this point where gravity is this, it can be this way, it can be any point on this, at any point where gravity is acting on this. If we come and bring the Y weights close, now the one acting on the X axis, if you come and bring it close, now by the time you stretch this one, you see that they have met at a point where this looks like a triangle. So the next thing, I have this to be the mg. I have this to be the weight on X axis. I have this to be the weight on Y axis. So simply, this is how we derive this. And then the angle that this will be making with this when I bring it down is not going to be theta. Remember we started this from this point. So I call this theta. So that is why simply, whenever we want to analyze this, we don't want to stress ourselves on how we derive this, but this is how we derive this. By knowing that Y axis, X axis, once you slide it at an angle, that gravity remains constant. So simply, I normally tell my students, if this gets confusing, just know that for you to derive the equations of body on an inclined plane, that is the dynamics of body on an inclined plane, simply know that the object is at an angle, and you have a triangle. And this triangle, this side because your weight on Y axis, this side because your weight on X axis, why this side because your mg. Very simple. And this because the angle that this object makes with whatever you analyze, that is your component, the X and Y component. Now, when you finish doing it, it's at this point that you employ your SOCA tool. So at this point, you say SOCA tool. So that you are not analyzing, can I get this? So you are not analyzing when it is sin theta, we know we are dealing with opposite over hypotenuse. So sin theta for so is going to be equal to opposite over hypotenuse. Yes. Now, if that be the case, I'll ask myself, the opposite side of this triangle is the side facing the theta. Is it not true? Yeah. So I have WX. Now, looking at this triangle, the hypotenuse should be this way. Yes. The longest side. So I have over mg equals to sin theta. So by the time you cross multiply, you now have that Wx is equals to mg sine theta. That is why we say that the weight acting on an inclined plane of the x-axis is given by mg sine theta. While the one acting on the y-axis is given by mg cos theta. Remember that we normally associate anything about x with cos, should be? But once it's inclined plane, the reverse is the case. And this is how we get it. So by simply remembering that underneath this, everything happening this way, this side, vertical is wy, while everything acting this way, this side is wx. And the force of gravity will always act this way. By the time you check the triangle you've made here, and what you've made here, what you've made here, you get that triangle. Even if I come and put it from here and I start here to have something small, you see that I've got down my wx, my wy. And this because gravity, which is gravity is equal to a multiplier of the mass. So very simple, very simple. So you now check the angle theta, which this makes with the mass. Very important. Very important. So now let's analyze for the y-axis. Let's analyze for the y-axis. I'm teaching you this so you remember how we derive it. But if remembering how we derive it is a problem, just remember that we moved y this side, move x this side, and then gravity acting straight. I will not just write gravity, normally write it with energy. Yes. So at this point, once we are done with deriving this, we now start to check what are the conditions of this when it's at rest. What is the condition of this when it's moving upwards? What is the condition of this when it's moving downwards? Okay, so let me draw.
Yes. If I come to your seat and you don't have the password, I'll collect your phone and transfer the money to my account. Just I'll ask just one question. Do you have the password? No, give me your phone.
Alright, now see, for car, which is cos theta, let's try to look for car which is cos theta. So cos theta will be equal to adjacent over hypotenuse. Now, that means that cos theta will be equal to the adjacent side of this. If I know this is the opposite, this is the hypotenuse. What is remaining is the adjacent. So I'm going that this is wy, all of hypotenuse is mg, is it not the if I cross multiply, I have that mg theta, yes, is equals to weight on y-axis. So for the vertical components of an inclined plane, what you use is that wy is equals to mg cos theta, and this is how we derive it. It's not hard. Just knowing that normally it's always this way, but when it's inclined plane it's this way. If you judge this by this way, the way you're moving will be vertical. Judge the way you're moving horizontal this way. Then if you put a line straight vertical, you will get that triangle. And when you analyze the angle, the triangle goes to the mass. It's not hard. Alright. So now that we've gotten the wy and we've gotten the wx, the next thing we need to ask ourselves is a body on an inclined plane naturally. As this body is here, if it's going this way, there's a force that, let's say you remove your hand from this thing now, let's say they are not applying any force to this thing. Remember the meaning in our down. Remember that anything going this way is actually, and anything going this way is y, right? So if I ask you now, naturally, let's say there's no force applied to this body and you come and put it here. Which direction would this body want to go to? You want to go down, Shebi? And as it's going down, you know it's going down in the x-axis. Shebi, you see it? Because remember that here no dash for x, one here for y. So it's going down, it wants to go down naturally. So anybody on an inclined plane naturally is going down in the x-axis. So it has a component in the x-axis that it wants to go down naturally. Even when it's going up, it has a natural component in the x-axis which is mg. And we say that for this, X-axis is going to be mg cos theta. Sin theta, sorry, what am I doing? Sin theta. You see it? So that natural principle that your mind always tell you, X is for cos. Once it's inclined plane, it gets changed. I see it? Yes. Yes. So if this body is going this way, naturally it wants to go this way when there is no force applied to it this way. That means that anything as this body is here, as it's moving this way, they're asking you for friction. There will be a force that wants to take you to the other direction. And since it's moving, we say that kinetic friction is the force that acts on friction that affects an object when it's moving, shaping. So naturally, if this object is moving this way and they give you something of friction, the diagram for dynamics is here is that this side becomes your F3. So naturally, if you put this object such that on this one, let it slide down. As it's coming down in mg sin theta axis. While the other side, the friction that will be there is Fk. Unless there is no mention friction, but most of the questions they will mention friction. So with this understanding, I want us to now analyze it when it's at rest, when it's moving upwards, and when it's moving downwards, so that we get formulas for it. Okay. I want to clean this. And I have to clean this because we now know what it's all about. We know what we need from it. So when a body is at rest, what type of friction is acting on that body? Static friction, shall So if static friction is acting on this body, now anybody, do you notice that the body on an inclined plane, we never have a time. It will never have a time when it wants to go and jump up. So it will never, and you know if you jump up, it's not going to be y-axis, and remember that anybody resting has the N this way, and then this one has the WY this way, and then you have the WX this way. Alright, now please, it's at rest. Static friction must be there. So the only forces that will be on this board when it's at rest is simply two forces, which is static friction and the force on the x-axis, which is W on the x-axis. When it's at rest, it will have nothing to do with kinetic friction because it's not moving. Kinetic friction only enters when it's moving. Shaving? Yes. So that means the only force that wants to act on this, the two forces that will act on this is the static friction. That, okay, you are at rest. We have that tendency to move, but we are still at rest. Then the x-axis that if you do as if you shift it more, it will come down. That's the only thing to present. But for the fact that it's not moving, everything will be equal to. Remember that in dynamics, everything we are doing about force will always be equal to ma. You say remember, and for the fact that it's not moving, A will be 0, which means everything will be equal to 0. So analyzing this about Fs. Even if I do minus Wx, or I do Wx minus Fs, everything will be equal to Ma, and A here will be 0. Which means that the total system will be 0 because there's no movement. 0. Which means if you pull it out, Fs, static friction will be equal to the x, weight on the x-axis. If you still this one, Wx will be equal to, are you saying it? So whichever way you do it, once the body is at rest, the dynamics there is simply such that you will have static friction is equal to weight on the x-axis. And we remember that this weight on the x-axis, if you remember when we solved, is given by mg. What I'm teaching you about this here. For robots. And we know with the red piece energy scientific, it's not hard. What I want to do is say this thing, say this thing, say this thing, say this thing, T angle here, TWX here, TWY here. Very simple. And there's the force acting this way, and You don't want to analyze the other one, so it's not hard. Alright, so it will be equal to, now we need to remember something. We need to remember something. Do you remember that when we did static friction, we said that static friction is equal to coefficient of static friction times normal reaction. Is it not true? Which means I can replace everything about this static friction with coefficient of static friction and normal reaction. Are you seeing it? So I can replace it with coefficient of static friction times the normal reaction. Now we need to analyze what this normal reaction is. Remember that it's the force that is going upward, should be negative. That one that wants to take it up. Anybody in vertical axis, the force that wants to take it up. Now let's say something. If I have, let's see something about it. If I have normal reaction and I have weights here, and for this inclined plane, the weight acting this way is W1. See now W1, negative, and this way, W1, here on the side. Shall we? Do you know what I'm saying? I need to be sure. I can go along the line and if I'm not sure, some people will start calling me back. So we must be going one step at a time. I see, I have my hand in this way. Now, if I want to judge this now, let's say I do N minus W1 equals to 0. That is no acceleration. That is as it's sitting down here. The force wants to go here, the one wants to go here, but no movement on the vertical axis. So there's no acceleration. M times A, M times 0 is 0. So which means that N is also equals to W1. Is it not true? And that means I know that W1 is equals to mg cos theta, actually. Which means that N is equals to mg cos theta. Is it not true? So because now the way movement is going on an inclined plane, the vertical axis. So for that reason, everything equals to MA. And even Manani applies. So the minute you see N, once you are treating inclined plane, you replace N with mg cos theta. And this is how this is. So I will just rush now and come here and say mg sin theta is equals to coefficient of static friction 10 times mg cos theta. You don't even need to cram anything. In physics, there is no cramming because anything in the will prove. Yes, we just be seeing the step. So coefficient of static friction times mg cos theta. So at this point, if I want to make coefficient of static friction the subject of function, I can also make it. So they can tell you, what can be given to you, they tell you, a body at rest on an inclined plane, did this, did that, then they can tell you, find the coefficient of static friction. What you will just do is, at the end of the day, remember this is what we analyze, you now make coefficient of static friction by saying, divide both sides by mg cos theta. Divide both sides by mg cos theta. So you see that this one will get that, this one will get that. Then the mg will get that. And we know that anytime sine is divided by cos, we have tan, shall we? Yes. So that means that for a body at rest, the coefficient of static friction is simply given by tan theta. Very simple. Very simple. It's not hard. The minute you get that diagram, that first diagram of rotating this and doing that, this side is the weight on x-axis, this side is the weight on y-axis. Gravity will always be vertical. You see that triangle, you're ready to show it. The angle it makes, and that's the main part. Okay. Okay. I will do it so you see. But please compare. What we get is lunchbox. No. What? You want to eat up? Should I give you money for my class? You guys finish. Don't worry. You promise what? Let promise you. That's my promise. I'm giving him. I will not buy for you. Now see, at this point because let me clean this side. Let's do it here. I have mg sin theta. Mg sin theta equals to coefficient of static friction mg cos theta. So if I want to make this one subject of the formula, I have to divide both sides by this one. So I have mg cos theta all over mg cos theta. In fact, I can cancel one. So I'm left with only coefficient of static friction. So this will cancel this. So I'm left with sin theta over cos theta, which will give me tan theta. So that is it. So for a body at rest, this is the formula used for the coefficient of static friction. But please, now let's say this body is moving upwards. Let's just do the C. The minute we move, give you the formula for this, give you the formula for this. We take it that we will introduce everything about dynamics. You understand? Even if we don't solve the calculations today, so that another course can end. We know that any other day we are coming, even on your own, you can start trying the questions. But any other day we are coming now, our business is to solve the questions. Because Saturday class, we go to the other calculation. We look at manual, we look at our EPF, we look at the practical man. Okay.
Look at past questions.
Look at past questions.
Yeah.
Okay, somebody called me. So let's analyze this case. So let's say I call this one case 1. We are done with case 1. We are done with case 1. So let's analyze case 2, which is a situation where the body is going upwards. So I think I figured out the only way for us not to be getting confused is I'm trying not to be going into so much details. Those things you might not have been here to it, I'll give it to you. Yes. Because I know, even when I derive this thing, as soon as I started drawing it line, before you know to say line is too much. But we need to improve the triangle, it's everybody do it. Now see, if this body is moving upwards, notice it, on another nail like this. How many forces did I tell you is acting on this? 2. Which is what? Now see, FK naturally this body, anybody on the climb plane wants to come this way. Which means that if he naturally wants to come this way, kinetic friction wants to go this other way. Now in a situation whereby you are not pushing this body to go this way, that's to go up. So as it's going up, and naturally G is always wanting to come this way. When G wants to come this way, kinetic friction is going this way. So if naturally G is always trying to go this way, and you are trying to push it this way, which means that you now have Ws. And then your Ws now is not going in direction of your kinetic friction. Are you seeing something? It's different from this case where we have Ws coming down and kinetic friction will be going in the opposite direction. I don't know if it's making sense. Naturally, see what I'm saying? Okay, let's start with this one before we enter this one so that you don't get confused. Naturally, this body, even if you don't apply force to this thing, naturally this body wants to come down. Yes, I will say that the force that is acting here when it's down is Ws. That is. Then, as you're doing this, kinetic friction is going this way. It wants to go in opposite direction to what you have here. Which means if I analyze this, I will have Wx minus Fk. Fk is equals to Ma. And because there's movement, they will be active. Now, if I analyze this, Wx is mg sin theta. Minus Fk, if you remember when we did this, kinetic friction is equals to coefficient of kinetic friction plus normal reaction. And normal reaction is mg cos theta, right? Then I have coefficient of kinetic friction equals to. So, you remember, so everything about this, I will replace this with this. So that I have minus coefficient of kinetic friction times mg cos theta is equals to ma. Is equals to ma. Now, I can analyze this. Let's say I want to get coefficient of kinetic friction, or I want to get acceleration. There are so many things they can ask you to get in this question. They can tell you get acceleration, and if they tell me to get acceleration, all I have to do is to divide both sides by m. Is it not good? So that this will cancel this. I said it. Yes, ma'am. Did you drink that? See, I said, if I have equals to MA, and let's say the question tell me a body sliding down an inclined plane, did this, like the questions were, did that. Now after everything, they tell us find the acceleration. If I'm to find the acceleration at this junction, that I'll be able to analyze what is going on here. That WS always wants to come downwards, and since it's sliding downwards, it's coming downwards peacefully. And every picture will be acting in this direction. And if I know that, it simply means that in that case, everything will be equal to MA. Reason being that mass of the body and the expressions of movement, which is acceleration, will be there. If they ask me the acceleration and they give me, I'll just divide both sides by m, which is normal to normally do. Divide both sides by the coefficient of that thing we're looking for. So if we do this will give way. So that we now have equal g sin theta minus this. I can still cancel. I can still say let this thing be the same as saying all over m. Shall we know? This can cancel. This can cancel. It's one mass we're doing. It's the same thing. So we are left with g sin theta minus coefficient of kinetic friction g cos theta is equals to a. I say it. It's not hard, but it's not every time they ask me to find acceleration. They can ask me to find the coefficient of kinetic friction. I say it. So if they ask me to find coefficient of kinetic friction, let's try to make coefficient of kinetic friction solid on the phone. Remember that this one is case 3. We're using this one to be case 3, case 2 now. So this is our case 3. So this is case 2. So let's now say it is not acceleration we are finding. Let's say we are finding coefficient of kinetic friction. So this thing is not hard. It's not about. Is it hard? It's not hard. It's not about sleep. The only thing you are doing, do you know why we are doing this thing? This thing is not hard. This side, the whole force is acting here. It's simply the one going this way and the one going this way. Remember we call these weights. Is it not true? Which we also call force on x-axis. So the one going this way and the one going this way. And we know we derive Wx from mg sin theta. So all the forces, so the forward one when it's forward minus the backward one, everything equals to m, which is the same principle we use now.
If you can forget about it, he was the formula that worked.
Okay, that's what he wants. Rubbish. Because you need to understand the processes behind what we're doing. So please, let's quickly find this one, coefficient of kinetic friction. So that we can run it again. Don't worry, time for formula is coming. Once you master it, once you start questioning, you don't need to be right again. You are always give me the answer, give me the answer. So remember we have initially okay. So to make this solid of formula, I have mg sin theta minus ma equals to coefficient of kinetic friction mg cos theta. Alright, I'll say the right sides by the coefficient of coefficient of kinetic friction, which is mg cos theta. equal to this. And notice that this is the same thing as saying mg sin theta all over mg cos theta minus ma over mg cos theta. So notice this can take care of this. So I'm left with sin theta over tan theta is what? Sin theta over cos theta is what? Minus m. So a over g cos theta. So if it's coefficient of kinetic friction, they ask me. So this is the formula. Whenever they ask me that the body, whenever they tell you that the body is sliding downwards, and whenever an inclined plane question is given, and they tell you that the body is sliding downwards, the formula to use for the coefficient of kinetic friction, because it's moving, its kinetic friction you should be talking about it, is simply the formula here, which is tan theta minus g or minus a all over g cos theta. And if the body is sliding downwards, and they're asking you to find the acceleration, the formula to use is simply g sin theta minus the coefficient of kinetic friction times g cos theta. It's not hard. Me, I know it's not hard. Because the only part where you have issue, students normally have issue simply getting that first on y-axis, first on x-axis, and knowing that this part gravity is energy. So let's get for case 3. Do case 3 for me. Do case 3. In case 3, find me, I'll go ahead and check before we solve it, and that was the last thing we'll do today. Find me the coefficient of kinetic friction when this body is sliding upwards at an inclined plane. Then find me the acceleration. Make sure you're doing something. You were moving around now. I saw when you entered. I asked. Yes, I said, see. Should you remember that in this case, this is going downwards, when the body is accelerating downwards, Shebi? And that is why this one, kinetic friction is going upwards, Shebi, because it's opposing motion. So in case 3, what you are doing for me is when the body is going upwards. So do it for me. So see Rita, let him educate you. Let him use this example and educate you. Let him now be that you don't understand us. We are not doing it together. We are not doing it together. Yes. Academically. Yes. No, I'm impregnating you academically. Yes. Definitely, if you've been paying attention since we started, we know that you've been breastfed. Yes, properly. Yes. Is that? This one is what we call coefficient of kinetic friction. Like this way sliding downwards, man. This one. Like this one. No, yes, this is case when it's sliding downwards. The one you are doing for me is when it's moving upwards. Which is case 2. Case 3 is sorry. So you are finding the coefficient of kinetic friction when it's moving upwards. When this body is moving upwards, and you are finding the acceleration when this body is moving upwards. Here I solve for when the body is moving downwards, and I solve for when the body is at rest initially. So you find me when the body is sliding upwards. These are 3 different cases that inclined plane question can come. Make sure you are doing something. In fact, once you know these 3 cases, see, even when this body is sliding upwards and downwards, notice that it's not jumping out of this plane to go upward. Notice that the vertical axis is just this way. Ready? So it's not moving out of this. So anything happening here, whether when it's going this way or when it's going this way, it's still on this x-axis. So there's no reason why you put W1 anywhere for this. Find me the coefficient of kinetic friction and the acceleration when this body is sliding upwards. Yes, we are getting it. That's the truth. The truth is that once you are teaching, people will be learning. What you will do, see how you do this thing, naturally, the WX always want to act downward, should we? While the other side will not be your FK if it's moving, which means forward minus backward there. That's what you think of. So always remember that the average is always which one is forward minus the one that is backward. So wait. What is that? It's sliding upwards. So no. Sorry. This is what we are looking for. Ask people near you questions because you're like, this is what we are looking for acceleration. While here, this is the formula we get. This is the natural formula we get, which is coming from this one, Wx minus Fk equals to Md. So we analyze Wx is mg sin theta, while Fk is coefficient of relative function, then mg cos theta equals to Md. So by the time you want to make this one solid, that is what we did. So look at the notes. So first, yes.
You ready for math? Warming up for math.
There are two ways to get that question. That's not complete it. This thing is not hard. Just push yourself. Push yourself. If I think that's enough. Yes. Ah, Right, but we'll do it together. Should we do it You are all running. You are all running. Now let's do it together. Let me see how my friends work. This is the first time she's showing me his work. Yes, you are running. I see. Let me see. Right. Some of you are just using Google. If you find the answer to Google, you may not use it, you don't get the answer. It's well. So let's analyze it with pride. But you understand it now, please, if you did follow the first and the second part, pay attention to this one. See, as this object is moving upwards, we know that naturally there is a force that wants this to always come down, shading, which will call what? W like shading, but the object is sliding upwards. The object now on this road is sliding upwards. And if this object is sliding upwards, when you move this thing, it simply means that kinetic friction will be going this way. I see it. So the best way to put this is simply, we're saying that the kinetic friction is going this way, that is F of K. It simply means that what I will have in this process, in this situation, is no longer something minus something, but rather a collection of forces. A collection of, which means I will have Wx plus Fk is equals to MA. Yes. So what I will have, notice, it is sliding this way, Shemi? Yes. So what I will have in this case is going to be a collection of force. Another way to analyze this, just like some of you did. Some of you did, don't worry. Some of you did Fk here. Then Wx this way. That is what some of you did. It's still correct because by the time you solve for the two, you will see that what you have here will still show the positive sign. Why are we using this? This is simply, if it's going downwards, if this one naturally goes downwards, and your Fk is going in this direction, but you now do Fk now being forward, then minus Wx equals to Ma. Why we are not making Fk subject of the formula, why I say we must use this is that frictional force can never be my forward force. Are you getting it now? So I can never come and make frictional force. It's an opposing motion. So I can never make frictional force my forward force. So that means it will give you the same answer, but this is the correct thing to use. What you are using in this system system is not a negative force, but rather sum of forces on that axis equals to MA. So this is going to be the same answer, but this is wrong. Frictional force is opposing motion. So it's not supposed to be a forward force. So I will have mg sine theta plus coefficient of kinetic friction mg cos theta equals to ma. And because my A is active, it is moving. I will not say this is 0, I will divide both sides by m. Divide both sides by m. So this is simply the same as saying I have m, I have n equals to A. And this is the same as saying mg sin theta over n plus coefficient of kinetic friction mg cos theta over n. And I know that this can take care of this. I know that this can take care of this. So that I have g sin theta plus, which is what most of you were looking for, because God will show you that. But that is not how to go about it. So g cos theta equals to A. So in case 3, what I have is a collection of forces. What I have is a collection of forces. So those two forces, what I have is that the two of them acting on that x-axis. In the x-axis, two forces are always there. The force on the x-axis and the kinetic friction. So when it is sliding downwards, it's obeying that force that is going downwards. Kinetic friction will go in this direction. But when it is moving upwards, in this case, the g still wants it to come down. And that of kinetic friction will be going in the opposite direction to that movement. So it's going to be a collection of forces. Any confusion? So it's not hard. So let's now solve for coefficient of kinetic friction. So if I'm to find the coefficient of kinetic friction, at this point where I have mg sin theta, I will analyze. Look at this is where I got that. I'm done with solving for A. I want to solve again for coefficient of kinetic friction. So I'm going back to put this formula. So if I put the formula, it's essentially saying mg sin theta plus coefficient of kinetic friction, then mg cos theta equals to ma. So what I'm doing here is now I'm looking for a way to make this subject of the formula. So if I want to make this subject of the formula, I say let this cross equality sign, shall we? And let this come here. So that I now have mg sin theta minus ma equals to minus, shall we? Mg cos theta. So let's start this. Now at this point I can say divide both sides by minus 1, shall we? Because I want this minus to leave now. Is it confusing? Yes. Which one? This one? Okay, move this one to the other side. We'll still get the same answer. But we are really mathematical. Okay, so this is that way. Me, I like easy something too. So let's do it that way. If that is the way you like it. So I have coefficient of kinetic friction, then mg cos theta equals to ma minus. But please, in this movement, there is no way you move it that should be a problem. Because once we employ all those mathematical principles, we still get the same thing. So now this is the same as saying to make this one subject of the formula, divide by mg cos theta, shall we? Then equals to ma minus mg sin theta all over mg cos theta. So you see that the mg cos theta will get out. So please, we are trying to be fast. So I now have coefficient of kinetic friction to be equal to ma over mg cos theta minus mg sin theta over mg cos theta. So you see that this can take care of this. This can take care of this. So I have A over G sin theta. Please, we are looking at our answer like this. Is it cos theta? Sorry. G cos theta. is then minus sine theta over cos theta. So which is equals to A over G cos theta minus and theta. I said it. So this is my coefficient of kinetic friction. So in summary, the two things we are looking at is that if this body is on a plane, when it's sliding downwards, it is obeying this mg cos sine theta, which likes it to come down. And the minute it's sliding, there will be a negative force, which is about F here. I see it when it's sliding down. And that means this one is naturally coefficient of kinetic friction, then mg cos theta. So you will do this one minus this one equals to MA. But when it is going up, if it's going up, kinetic friction will no longer be going this way. It will act in the opposite direction, and this one likes to come down. You have a sum of forces. So equals to MA. So that is simply the principle that gives you that answer. So with this said, we'll be stopping here. But please have it in mind that tomorrow is going to be all about calculation. So if you notice, even the PDF that we have there are so many questions we did not solve. So thank God we now have the formula how to derive it. From tomorrow, it will now be how to use those formulas. And please, when coming tomorrow, come with your graph notebook, come with your physics manual. Yes, very important. If possible, come with a notebook that we will use to be taken down. All the solutions that we will be giving for that manual. Highly important. Thank you very much.